unfolding. Richard, good afternoon to you.
Hi.
We have been showing some incredible images here on Sky News, and I don't mean incredible in a good way. It seems that no part of the world is untouched at the moment by extreme weather. We've been seeing floods from Italy to China, wildfires in Siberia and LA. In fact, 65% of the US is currently in drought. What's your assessment of what we're witnessing at the moment?
Yes, well, this is an expected occurrence of the fact that we're emitting vast quantities of greenhouse gases into the atmosphere. That's heating the atmosphere up. That's causing hot events to become hotter. It's drying out the soils, so that amplifies even further these heat waves. But also, the fact that the atmosphere has this greater thirst for water means that there's more moisture in the air that's sucked into these storms. And so when you do get weather events causing heavy, sustained rainfall, the associated flooding is much worse. And this produces these, what some people sometimes call black swan events, these things that appear absolutely unprecedented.
Yeah, we keep hearing about flooding being once in 100 years, once in 1,000 years, but it's going to become more commonplace. You say this is an expected occurrence, but did scientists expect it to happen as quickly as it has been?
Well, it's been shown by all the lines of evidence, so observations, understanding the physics of what's going on, but crucially as well by using these detailed computer simulations. So running lots and lots of simulations to show all the different possible weather patterns. And by doing that and looking at all the evidence, yes, these types of events are an expected consequence. Where there is more difficulty is knowing exactly where and when these events will happen in the future, and being able to resolve all the fine-scale impacts that affect people and ecosystems.
Richard, it feels like we've been wringing our hands over this matter for decades now. This really is the big question. It has been for so many years, but it seems more pertinent now. What do we do about it?
Yes, well, the simple thing is to drastically cut greenhouse gas emissions, particularly carbon dioxide, across all sectors. It's got to be done rapidly. It's got to be done across all sectors of society. And you sometimes hear people say, if we all do a little bit, then that's half the job done. Unfortunately, it's not. If we all do a little bit, we'll achieve a little bit. And that's why we need governments to agree across the world ambitious targets for reducing carbon emissions across all sectors. So that's one thing, but as well as limiting the amount of climate change, we're also inevitably going to have to adapt to it.
The 2016 Paris Agreement saw a pledge to limit warming to 1.5 degrees and a commitment to keep it well below 2. Given what we're seeing, does this need to be completely rewritten?
No, these targets are what we need to aim for if we're going to limit dangerous climate change.
Do we need to get there quicker?
We do need to get there quicker, yes. So these targets have been set. There are pledges by all different countries, but these ambitions need to be ramped up if we are going to limit climate change below 2 or even 1.5 degrees C above pre-industrial times.
Perhaps you can give us a little bit of a lesson here. This is the science part, as they say. When the temperatures rise, there is a knock-on effect. There becomes an unpredictable cycle. Talk us through that cycle, a lot of which we're seeing now, but talk us through the events that unfold.
Well, there are certainly amplifying effects. So as the temperature rises, the atmosphere has a greater thirst for water. More water in the atmosphere adds to the greenhouse effect, that adds to the heating, so that can cause heating to increase. But there are also other knock-on effects as well, as you say. So, for example, we've seen wildfires and we've seen melting of ice. So changes in the vegetation, drying of continents, that can exacerbate impacts in certain regions. Changes, melting of vast areas of ice, that can alter the atmospheric wind patterns, and that can shift the climate in certain regions. So all these effects can, like you say, they're knock-on effects of the initial warming that can add to the extreme nature of climate change.
Yeah, I think it's important for people to know the path and the route that this all takes. Just before this show came on air, David King from the Climate Change Advisory Group was talking to my colleague Jane Secker, and she asked him whether any of this is reversible. We talk about halting and stopping what's happening, but how much can we do some climate repair, if you like? And he was talking about refreezing the Arctic Circle. Tell us a bit more about that, because a lot of people will be quite surprised to find that there are some elements that are reversible to the damage that's being done to the planet.
Well, certainly something like Arctic ice, if you were to somehow reduce the temperatures back to maybe the temperatures of a few decades ago, Arctic ice would quickly grow back again. So that's something that is reversible. But what's more problematic is something like sea level rise, because we've only just started to heat the surface layers of the ocean, which then expand. We've only just started to melt the large ice sheets like on Greenland and West Antarctica. And so these will take hundreds of years to come to their new equilibrium. So it'll take hundreds of years to heat up the deep ocean, hundreds of years to melt finally these large ice sheets. So unfortunately, things like sea level rise are less reversible on human timescales. This will carry on over hundreds of years.
Okay, Richard, really good to talk to you. Richard Allen, Professor of Climate Change at the University of Reading. And thank you for adding more detail to our story today. That stark warning that climate change is here. We've seen the pictures. It's on our doorsteps. But Richard Allen there talking about the steps we can change